All right, so I promised we would talk about variables as the base in video for 2.1. So here we go with video 15, variables as a base, math 9. What does that mean? That means we now have variables as our base. Any letter you want, that is now our base. But this will still exist, and this will still exist. So be aware of the difference. It's exactly the same as how we worked with numbers. We're just dealing with letters because the letters represent any potential number. So it's nice to keep things abstract. So here we go. I'm multiplying a common base, and this first one here, all my x's. I only have x's. So I'm multiplying. What do I do to the exponents? Add them together. So 4 plus -5 plus 2. I get x to the 1, which is just x. So it doesn't matter what x is, any set of numbers in that write-up will be just x. Now, here I have a bunch of r's. Well, here I have an issue, okay? A negative exponent has no bearing on the negative or positive of my base, even if it's even or odd. It doesn't make a difference in this case because there's no brackets, right? This is forever negative. So I have -1, and then r to the -3. And then -5, and then this forever positive, even an exponent in brackets, is just times r squared. So I know my answer is going to be negative. I know the base is going to be r, so I'm just adding 2 and 5 is 7, and -3 is 4. So this time, there we go, forever negative. Now, if this were to be a scenario you see, and I'm not going to give you any in our work because I don't want to overly confuse you. If it's going to be a forever negative, it'll be forever negative. But if you had this scenario where you had a negative number in brackets to a negative exponent, the negative doesn't matter, but the even or odd still does. So that's bonus, okay? This would be a forever positive, but still to a negative exponent because that is even. But again, I'm going to try and keep that out of our work, but just be aware of that. So division, what did we do when we divided a common base? We subtracted the exponents. So here we have x to the 4 minus 3, which is again just x. Here we have to deal with our negatives. So here's an example, right? Odd exponent, even though it's a negative number, it's odd and a negative in brackets, which means forever negative, forever negative. If you have 2 forever negatives, it means your answer is going to be positive because you'd have that -1, r to the 8, and you'd have -1, r to the -3, right? The negative on the exponent has nothing to do with the negative on the base. Those cancel. But then 8 minus -3 is 11. Power to power, same deal. T to the 4 times 3, which is t to the 12. Now here we have that situation where you have a negative on the inside, so look at the outer exponent. It's odd, so this is forever negative. So negative z to the 14. And then 0 power, well, t to the 0, just like everything else, is 1. But here, watch out for the negatives. This is a forever negative statement. -1 times x to the 0 means -1 times 1, so we get -1. So as you can see, variables make no difference with respect to the rules as far as numbers went. It's the same stuff. Watch out for the negatives. The variables just keep things abstract. Same deal though. Great work. We are almost done.